Hello everybody and welcome to our new tutorial related to the aerospace industry. Today we are going to talk about a subject that it's always in our minds, especially when we are safety engineers, avionics engineers, system engineers. And whenever we are doing our design, we pay a lot of attention to safety. The French, they say, dans la vie, il faut savoir pour prévoir et prévoir pour agir. Mais chaque fois que nous avons fait cela, ça n'a pas donné des résultats. Donc, il faut, en quelque sorte, changer de méthode. Well, I'm not going to translate what those French, they say from time to time. For me, it has no meanings, but the French is a wonderful language, and I'm sure that one day you're going to understand what I'm talking about. Let's talk about ARP 4761. This is the Safety Assessment Process, Guidelines and Methods. The other document that we'll talk about is the ARP 4754, which stands for Aircraft and System Development Process. They are guidelines, but God forbid, if you don't do what it's written there, FAA is not going to say, good job, you show me compliance, and you're not going to certify your product. And if you don't certify your product, you're not going to sell it. If you cannot sell your avionics package at the component level, subsystem level, system level, aircraft level, you can get money in your account. You are going to have cash flow issue and you are going to file bankruptcy. So those two standards are really important because they are running in parallel and with interactions. Of course, you have to take care of what we call system design information, function failure, and safety information. Why 4761 is so important in the aerospace industry? I will let you know why. Because it provides details of the activity that are part of ARP 4754A. And it shows compliance with FAA 14 CFR, Code of Federal Regulation 25.1309. 4754A defines the main process, and it refers to 4761 Appendix D and E. What you have to understand is that it's another document that is more and more popular due to the fact that we are now very concerned about doing design that is based on model-based development and validation. So we use MATLAB Simulink, we use Python and other tools that allows us to accelerate the validation and the verification process, and you are going to be at the end of the game a winner at the validation and verification process level. So MBDV, it's incorporated in DO 331. What I want to say also about the ARP 4754 is that, first of all, it covers the functional safety, and also it gives you a lot of information about the DAL, Delta Alpha Lima, Development Assurance Level. Also, it helps you with the development process, certification, complete aircraft development, cycle, system requirements, system verification. And why the development assurance level, the so-called DAL, is so important? It's important because it's defined the level A as catastrophic, level B it's defined as hazardous, level C is defined as major, and level D as minor. And according to development assurance level, you'll know for sure how many verification methods are required to satisfy FAA and to show compliance when you have to deal with those final executive testing and results reports. Of course, 4754A, it's supported by other standards, DO-178C, right, which is software consideration for airborne equipment, and DO-254, which is the equivalent of the DO-178C, but not at the software level, at the hardware level. They are very, very, very important documents. They give us a lot of information, some checklists that are so important. This activity needs to be done with requirement management, task management, and configuration management in order to have traceability. And this traceability, it helps you to have consistency. And when you have consistency, it means that you prove to FAA that you can perform audits. They can perform audits. They can help you. The so-called SOI FAA audits that are sometimes in our attention. Because FAA is always asking you, show me compliance. Going back to ARP 4761, whenever you have a good configuration management and change management in place, it helps you to perform multiple analysis methods. Safety requirements, safety architecture, system safety assessment, the so-called SSA, system functions, functional hazard assessment, the FHA, preliminary system safety assessment. If you put a P in front of SSE, you get PSSA, the failure conditions, risk classification, FMEA, it's always on our lips, FMEA, all right? A failure mode and effect analysis. Also the failure mode effects and criticality analysis, fault tree analysis, FTA, and the common cause analysis, CCA. Why the fault tree analysis is important? It's very simple. You crank the machine at the component level, at the subsystem level, at the system level, at the aircraft level, and then at the end you ask yourself, do I show compliance? Do I get the right number to meet different levels, catastrophic, hazardous, and so on? If you don't meet the right numbers, the values, it's questionable your design. Something is not working properly. You have to lower those values, and the way you're doing this is by considering a redundancy channel, a parallel activity that will reduce the workload of your software, especially hardware load. Sometimes you have to do that for safety purpose, of course. So by doing that at the very first stage, it allows you to invest in your design, and you will never end up with some requirements that are going to be wrongfully validated. You get them into the verification process, and your team, which has to be a different team from the designer, so the verification team has to be independent from the designer team to have a certain freedom, right, and independence, of course. And those guys, they will say, these requirements, I'm verifying this requirement and looks good. It's a pass in terms of verification. Yes, it's a pass because it's there and it was not supposed to be there. That's the point. So FTA, the fault tree analysis, is also involved in FHA, PSSA, and SSA. But what is important to understand, the V model, life cycle of safety and development process. But we will talk about that later in another tutorial. Thank you very much. It's Eduard Philip, Principal Avionics System Engineer. I wish you a wonderful day and see you soon for another cartoon. Bye-bye. And make sure your number of takeoff will be always equal to the number of landing. Happy tester, thank you very much.